Hello, my name is Maria Miller from mathmammoth.com. In this lesson we're going to study compound events. And that means that we have two different events. And in this lesson we're only going to look at compound events where the outcome of the one does not affect the other. For example, let's say that I toss a coin and I roll a die. Definitely these two are independent events. Independent experiments, because if I toss a coin and whether I get heads or tails, it shouldn't affect what I get on the die, right? And one way to examine this situation and find all the possible outcomes is to draw a tree diagram. And I have started it here. The tree is basically upside down, so that here's the root of the tree. And my first experiment has two possible outcomes, either heads or tails on the coin. And then I continue the branches. If I get heads on the coin, then what are the possibilities, what are the possible outcomes when I roll a die? The 6 possible outcomes, right? I could get 1, 2, 3, 4, 5 or 6, so I will continue the branches like this. 1, 2, 3, 4, 5 and 6. And the same happens here, of course. Okay, and now I have all the possible outcomes. I will write them here. One possible outcome is that I get heads and 1, right? Or I can get heads and 2, heads and 3, heads and 4, heads and 5, heads and 6. Or I can get tails and 1, tails and 2, tails and 3, tails and 4, tails and 5, tails and 6. So we see that there are 12 possible outcomes, and they are all equally likely. And now we can find these probabilities. What's the probability of getting heads and 6? There's 1 here, 1 favorable outcome, and of course 12 total, so this is 1/12. What's the probability of getting tails and then an even number? Okay, over here I have these favorable outcomes, T2, T4 and T6. So I have three favorable outcomes and then 12 in total, so it is 1/4. And what is the probability of getting heads and not getting 5? So here I have heads and 1, heads and 2, heads and 3, heads and 4, and heads and 6. Those are the favorable outcomes. I have 5 of them and then 12 in total. Now, another way to examine the sample space or examine all the possible outcomes is by just listing them, which here I ended up listing all the possible outcomes, but I got there by using the tree diagram. Toss a coin 3 times. What's the probability of getting heads and heads and heads? Heads on every toss. I can just list, logically in my mind, think and make a list of all the possibilities that there are. I could have, on the first toss I could have heads, on the second I could have heads, on the third I could have heads. Or I could have, on the first I could have heads, on the second heads, and on the third I could have tails, right? And then I could have heads and then tail, heads and then tails, heads and then tails, and then either heads or tails on the last toss. And then I could have, this is now all the possible ones where I start with heads. So if I start with tails and tails, and the last one is either heads or tails. And then I can have tails and heads, and the last one be either heads or tails. So that should be all the possible outcomes, right? And now the probability, this one here, okay, there's only 1 favorable outcome and 8 in total. So this probability is just 1/8. Here we're going to roll 2 dice and find these probabilities. Rolling 2 dice is a very common thing in many different games, and so people have studied this situation carefully. Here's a table or a diagram that we can use to study these probabilities. 1, 2, 3, 4, 5 and 6, these are the possible outcomes for the first die, and then here are the possible outcomes for the second die. So each dot here is 1 possible outcome in my sample space for this rolling 2 dice. For example, this dot here would mean 2 on the first die and 3 on the second die, okay? And so to find the probability that I roll 6 and 6, okay? that would be this particular dot here is 6 and 6. That's just one dot, right? And there's 36 possibilities in total. So this is 1 over 36. And each one of these outcomes is equally likely, which is of course important to note. Now, the probability of getting 3 and 5 will also be just one particular dot here, this one. So again, the probability is 1 over 36. Now, what about if we are just interested in this, whether we get 3 and 5 or 5 and 3? In other words, on first die we might get 3 and on the second 5, or vice versa. On the first 5 and on the second die 3. We will just roll 3 and 5, you know? So then you will find here 2 dots, the 3 and 5 dot, and then the 5 and 3 dot, those two. And so this probability is 2 over 36, or 1 over 18. And then, in many games, people are interested in the sum of those 2 dice that you roll. Let's say, what's the probability of getting the sum of 7? And now we need to find the favorable outcomes here. For example, if I have this dot here, it would have 2 and 2, so the sum would be 4. That won't count. But for example, 1 and 6, that would be this one here. And then 2 and 5. If I roll 2 and 5, or I can roll 3 and 4, 4 and 3, 5 and 2, 6 and 1. So there are 6 favorable outcomes for this particular event. So I get 6 over 36, which is 1/6. How about if we want the sum to be 10? Then I cannot roll 1 at all. 1 and, I mean, there's no 9 here. 3 and 7, 4 and 6. Okay, I could have 4 and 6, 5 and 5, 6 and 4. So there's 3 favorable outcomes, 3 over 36, which is 1/12, exactly half the probability of getting the sum as 7. You could also use this chart to examine that what particular sum is most likely, are you most likely to get when you roll 2 dice. And it turns out that the sum of 7 is the most likely one to get. For example, this here, you get the sum of 4 on 2 dice. Your only possibilities are 1 and 3, 2 and 2, 3 and 1. Or to get the sum of 6, you would have 1 and 5, 2 and 4, 3 and 3, 4 and 2, and 5 and 1. That's 5 favorable outcomes. But this one has the most, 6 favorable outcomes. Okay, we're all done with this lesson, and I hope it was helpful.